We are going to be solving the problem x y prime is equal to 2y, and the way we are going to be doing this is with the separable kind of notes. So to do this, we want to separate this. The first thing that we're going to want to do here is we want to look at this y prime. And we know that this y prime is equivalent to dy with respects to dx. So what we're going to do here is rewrite that. X times our dy over dx is equal to our 2y. Now we know this is separable, and the way I look at this and can see if it's separable or not very easily is if we have a lot of multiplication, or in the multiplication is all together like this. So it's kind of hard to explain, but looking at these you'll get a better handle of it over time. So we're going to want to separate this. We want the y's to go on one side and the x's to go on the other side. Now this matters with this right here. We want our dy and our dx to be in the numerator. So if we just write the dy and the dx's out, we're going to have dy, and then we're going to have this equal to our dx. So this is step 2, kind of rewriting it out. And so that means our y is going to have to go on the other side. So we're going to have 1 over y, and then our 2 can stay over here. We'll have 2 divided by x. So this is going to be our equation. Now for step 3, and in step 3, we are going to want to take the integral of both sides. And we can rewrite this equal sign. We're going to want to do this with respects to whatever derivative, or not derivative, but whatever d we have on each side. So like on the first one, we want to take it with respects to this dy. Now how do we integrate this? If you don't know how to integrate any basic, what we're going to look at is the general equation. So the general equation for integrals is where we have, let's say, integral of x to the n. This is equivalent to x to the n plus 1 over n plus 1, and then we have plus some constant right here. So that's the general equation. Now this is when our n does not equal to a negative 1. When it does equal to a negative 1, the integral of our x to the n is going to be and then we could just write this n as like a negative 1, because that's exactly what it's going to be. If it is x to the negative 1, this is equal to ln with the absolute value of our x plus c. And that's exactly what we are going to use here. So in step 3, we have our ln of y, and then we have plus c is equal to, and then we have a 2 times our ln of x plus c. Now the c's aren't going to subtract from each other, they're going to combine because they're constants. So step 4 is going to be rewriting this. We're going to have our ln of y, and then it's a equal to 2 ln of x, and then plus c. Now from here, what we can do, we want to simplify this, we can get rid of our ln's, and all we're going to do here is raise everything to the power of e, and this can be in parentheses. Remember, when we have something like this, the rule for this particular part is this is equivalent, so we can write it as equivalent to e raised to the 2 ln of x, and then this is being multiplied by your ec. That's whenever we have like an addition or subtraction. Notice how when we have multiplication or division, we don't break it apart. So that's what we're going to have here. And our e and ln, when they're together like this, they're just going to cancel out. So this is going to be out like this, and our e right here, we're going to have to do a little bit extra for this one. We're going to actually have to bring this 2 up here to be squared. So just for this one, in this problem, we have an e, and then it's raised to our ln of x squared. So then we can get rid of our e and our ln, because we couldn't do it the other way. And so when we rewrite this, we are going to have a y is equal to, and this is going to be equal to our x squared, and then we have a plus c. So that's going to be the answer for this problem. That's how we would go about doing it and looking at anything like it.